Chemical engineering is all about creating means to convert matter into a more useful form. To put it more simply, we maneuver molecules.
Most chemical engineers work on complex problems that tie together chemistry, they tie together physics, they can tie together biology, and ultimately we deal with things on a huge variety of scales. So we do work all the way down to the molecular scale, down to the nanoscale, and then all the way up to large-scale processing. And that's really what sets chemical engineers apart.
I think chemical engineering is really just the study of how things are made. You can go into cosmetics, you can go into environmental, you can go into medical, you can go into food, you can literally do anything you can think of, but it just ties into chemical engineering.
If you want to lower dependence on fossil fuels and you want to have renewable chemicals, renewable fuels, and then even improve batteries, fuel cells, then a chemical engineer can do all of that.
What I see as the future of a student who comes in and engages with healthcare from a chemical engineering perspective is that you're going to be involved in all of these major breakthroughs. We've got cancer therapies, we've got issues with an aging community, we've got all sorts of things that are really going to be major issues ongoing. And students who come into this program absolutely will have the tools that they can be a part of that solution.
So chemical engineering provides students with a very broad base of knowledge that they can apply to a lot of different kinds of applications. So we have students that go on and work in a variety of industries, everything from the chemicals business to agribusiness to renewable energy. All of those things are kinds of chemical engineering problems.
One of the major goals of data analytics tracks is that we want to introduce our domain experts, which are our chemical engineering undergrad students, to fundamentals as well as applications of these various machine learning and artificial intelligence methods, and applying these tools to develop new knowledge about these processes or new materials.
The Unit Operations Lab, or the UO Lab, is a capstone course that our chemical engineering students here at Virginia Tech take, typically between their junior and senior year. The goal of the course is to provide the students with an opportunity and experience to really apply all of the things they've learned in their courses that they've taken as freshmen and sophomores and juniors to real-world, more hands-on kinds of situations. So they work with larger pieces of equipment in groups, open-ended objectives, to really try and challenge them and give them a real-world experience that they can use in their future careers. And so the skills that we teach them in all of the coursework leading up to the UO Lab are primarily theoretical knowledge, right? We provide the foundational knowledge, the math, the physics, the chemistry that they can use to tackle different kinds of challenging real-world problems. And what the UO Lab does is provide the students an opportunity to kind of bring all of that foundational knowledge to bear on real-world kinds of problems.
And there's also ChemiCarb and ChemiCube, two fantastic design teams. You can travel across the country at least once a semester to compete in competitions, and it's fantastic.
One of the things I really love about here, and before I even came here, I realized this is one of the most friendly environments I've been part of.
Blacksburg is a really awesome place to be. It's beautiful.
I think it's a place where people can just get along. In my cohort, there's a lot of people from different countries or different places and different age groups as well.
Our mission is to teach and train the next generation of chemical engineers, to give them the tools and prepare them to solve the problems of society.